Throughout the Cold War, the US military continuously sought flexible, lightweight weapon systems that could deliver powerful firepower to adapt to emerging forms of warfare, especially rapid deployment and airborne assault operations. The ambition to integrate multiple combat capabilities into a single platform, combining high mobility, air transportability, and advanced weaponry, led to the development of a series of experimental military designs. Among these, the M551 Sheridan stood out as one of the boldest, yet most controversial efforts. Introduced in the late 1960s as an armed reconnaissance and airborne assault vehicle, the Sheridan featured a super-light aluminum alloy hull paired with a 152mm gun launcher system capable of firing both conventional rounds and guided anti-tank missiles. However, these once celebrated innovations became liabilities on the battlefield, ranging from its thin, vulnerable armor and unstable weapon systems to what was considered a rushed deployment process. As a result, the M551 Sheridan came to symbolize the limitations of military technology when it outpaces thorough testing and practical operational needs. Born in the context of the Cold War, the M551 Sheridan was designed to meet the US military's demand for high mobility and rapid deployment, especially after the Soviet introduction of the amphibious PT-76 tank. From the outset, the Sheridan was required to be air-droppable and capable of crossing rivers independently, prompting engineers to optimize weight by using aluminum alloy for the hull and wheeled steel for the turret. The development program began in 1959 under the designation AR-AAV. The MX551 prototype debuted in the early 1960s, but early tests quickly revealed the limitations of the 152mm M81 main gun, a weapon system capable of firing both conventional rounds and Shalach anti-tank missiles. Despite its impressive firepower, the system was prone to malfunctions, especially in humid environments such as Panama and Vietnam. The M551 Sheridan was armed with the short-barreled 152mm M81, M81E1 main gun, capable of firing both conventional shells and MGM-51 shelling anti-gun tank missiles. This system allowed it to engage armored targets at distances up to 3,000 meters. Common ammunition types included heat TMP, and canister rounds containing thousands of metal flechettes for use against infantry. The vehicle carried between 20 and 30 shells and 8 to 10 missiles. However, the missile guidance system proved unreliable in combat conditions. Secondary armament consisted of coaxial 7.62mm machine gun, such as the M73, M219, or M240, with about 4,000 rounds mounted on the turret roof. Was a 12.7mm M2 Browning heavy machine gun operated by the commander, carrying approximately 1,000 rounds for use against infantry, light vehicles, or low-flying aircraft. The vehicle's armor was primarily made of aluminum alloy, while the turret was constructed from welded steel. The frontal armor could withstand penetration from 20mm rounds, while other areas offered protection only against 14.5mm rounds or heavy machine gun fire. The Sheridan featured aluminum foam to avoid buoyancy for amphibious operations and was equipped with NBC, nuclear, biological, chemical protection systems. The Sheridan was powered by a turbocharged Detroit diesel 6V53T engine, delivering around 300 horsepower, paired with an automatic Allison TG250 2A transmission. Its top speed ranged from 69 to 72 km per hour, with a water forging speed of approximately 5.8 km per hour. Operational range extended between 560 and 600 kilometers. The vehicle measured 6.3 meters in length, 2.8 meters in width, and stood about 2.3 to 2.9 meters tall. Combat weight varied from 15.2 to 17.4 tons. The crew consisted of 4 members: driver, commander, gunner, and loader. Amphibious capability was provided by inflatable skirts around the hull. Through the vehicle's low speed in water made it vulnerable to enemy fire during river crossing. The Sheridan was also the only U.S. tank designed for airdrop by C-130 or C-141 aircraft using the LAPES, Low Altitude Parachute Extraction System. Initial fire control included the M179 periscope and M44 infrared device. The upgraded M551A1 featured the AN/VVG-1 laser rangefinder. The M51A1 TTS variant was equipped with the AN/VSG-2B thermal sight, similar to that on the M60A3 tank, significantly enhancing night fighting capabilities and performance in low visibility conditions. Despite its powerful armament, the Sheridan's thin armor made it highly vulnerable without adequate support. The lightweight armor, designed to enable airdrops and amphibious operations, became an inherent weakness, forcing crews to rely on mobility and avoid direct confrontations. Although intended for airborne deployment and river crossings, these features were rarely used in combat. Preparing for water forging was time-consuming, and the vehicle's speed on water was very slow. Airborne operations, such as those in Panama, resulted in significant losses, even in Vietnam, where terrain favored amphibious maneuvers. Sheridan tanks saw no recorded combat river crossings. These limitations raise serious questions about the real-world effectiveness of the Sheridan's specialized design. The M551 Sheridan was first deployed to Vietnam in early 1969, with about 200 units serving primarily in U.S. armored cavalry and infantry units. The vehicle carried out various missions including reconnaissance, night patrols, and direct fire support for infantry. Its 152mm cannon, firing powerful heat and flèche beehive rounds, proved highly effective in battles, especially in Tay Ninh and Bien Hoa. However, the thin armor made the Sheridan highly vulnerable to mines and anti-tank rocket launchers, causing heavy casualties among crews. Additionally, the cannon and ammunition systems often offered malfunctions due to high humidity, reducing the rate of fire and endangering crews. During Operation Just Cuz in 1989 in Panama, 14 Sheridans were deployed, with 10 of them airdropped directly into the combat zone, marking the first time tanks were used in this way in history. The Sheridan helped create an element of surprise and overwhelm the Panama Defense Forces, which lacked anti-tank weapons and experience fighting armored vehicles. During the Gulf War of 1990 and 1991, approximately 55 Sheridan tanks from the 82nd Airborne Division were deployed mainly for reconnaissance and fire support missions, deliberately avoiding direct confrontation with enemy tanks. Notably, the Sheila missile was used in combat for the first time, successfully destroying an Iraqi tank. Overall, the M551 Sheridan demonstrated good effectiveness when employed in appropriate roles and environments, but remained limited by its thin armor and reliability issues. Throughout various conflicts, the Sheridan reflected the U.S. Army's evolving tactics to maximize its strength while minimizing the risk associated with this vehicle. The M551 Sheridan represented bold but ultimately imperfect breakthrough in the U.S. Army's effort to develop a versatile light tank. The vehicle embodied a challenging balance between firepower, mobility, and protection on a lightweight platform, but revealed numerous technical limitations and reliability issues in actual combat. Despite these difficulties, the Sheridan played a significant role thanks to its unique airdrop capability and deployment within airborne units, such as the 82nd Airborne Division. It demonstrated the value of organic armored firepower in operations requiring high mobility and surprise. The legacy of the M551 Sheridan goes beyond its technical shortcomings and relatively high casualty rates. It serves as a valuable lesson on the limits of military technology and the importance of rigorous testing protocols. Attempting to integrate multiple unproven technologies into a single platform exposed major risks and reshaped the US Army's approach to armed vehicle development in subsequent projects. The Sheridan remains an important case study, contributing to a deeper understanding of the suitability of tank designs for real combat roles and highlighting the critical value of reliability and maintainability in modern military systems.